Hey guys, here's a video for those examples on that very last page from the notes today that we ran out of time for. I wanted to make sure we got through those rotations about a point other than the origin, and we had no time to do these two. So here's a quick one. In some ways these might actually be easier than the ones we were doing in class today, because all you have to do is really kind of visualize how things match up. So one of the things we said was when you take a figure and you do any kind of congruence transformation like a rotation, reflection, translation, your object stays the same size and shape even though it may change its orientation. So if this quadrilateral is rotated however many degrees, 110, it doesn't matter, whichever direction, all the lengths of the sides stay the same. So you just have to visualize which sides match up with which. So if I'm looking here, the 7y, if I rotate that exactly, the 110 degrees here, it's going to match up with this piece. So this length and this length have to be the same thing. How about if I do this piece, right? Sort of the top right, if you will. This segment here where the 4 is. If I rotate that, that's going to end up where this dotted line is. So those two would be the same. And so on and so forth until you find the ones that match up that they actually need to solve the problem. So, the 6 right here would rotate around to here. 1, 2, 3, 1, 2, 3, etc., etc. And then those two would match up. So in this case, the ones you want to actually match up, of course, are the ones that have the variables with the values and see how you go. If we do start with the 7y, there's nothing wrong with writing this. But as you could probably tell pretty quickly, we're not going to be able to solve that without more information. So maybe we'll pick a different one. The 4 goes here. Not sure that's going to help. But the 6 lining up with the 3x, I think that's going to be the key. So now x is 2. We can use that here and get 7y equals 6 plus 1. Right? Plug in 2, you get 6. So 7y equals 7, so y equals 1. And now you've got both pieces. Oops, sorry, didn't realize I got cut off. There we go. Okay, so again, these two pieces match up because the rotation holds their length, and these two pieces match up, same reason. Once I get x, I can solve for y. Maybe you saw this one first. That's great. Okay, it doesn't really matter which one you see first. You still have to do them both, and it's just a matter of matching up the ones with the right pieces. So we'll just do the bottom one here. Hopefully you can see this piece here, 95 degrees. If I rotate that around, is going to match up here. If it helps, you know what you could do too, if you're having trouble visualizing it, put a piece of tracing paper over it, right? Put a piece of tracing paper over it. Here's the center, and literally just rotate it until it lines up. Until it lines up. I shouldn't have used a sticky piece of paper. It's got a little sticky thing on the front. There we go. And then you can see it lines up just right. Okay, I got all this sticky stuff here. So that is clearly this piece here. So the 2x plus 4 would actually equal 2y, and we're off and running. The x plus 2y looks like it matches up with the 13. Equals 13. And now it's just a matter of solving. Now this one I can't just get x directly or y directly. I'm going to have to solve a system, and it's just a matter of what your preference is for style. I don't know. I guess I can multiply through this one by -2. I could solve for x and plug back into the into the first equation and go from there. I don't know which way you guys feel is easier. I look at this really quickly, and to me, actually, you know what you could do? See how these are both 2y? If I rewrite that first equation, watch this. 2x. If I bring the 2y over, I'm going to get -2y. If I bring the 4 over to this side, I get -4, and maybe that's actually the easiest way to do it. Okay, it doesn't really matter. Whichever method you choose, it should work. So I'm going to combine these two equations. That's 3x, that cancels, equals 9. So x equals 3. If x equals 3, I can plug it back in somewhere, wherever. I'll plug it back in there. That's going to be 6 plus 4 equals 2y. So y equals 5. Right? 10 divided by 2 is 5. Okay, process is the same. Match things up piece by piece. If it helps, trace it and actually turn the paper if you think that'll be helpful. Eventually it'd be nice if you could just do them from visualizing it, but then the algebra kicks in and you finish off the problems. Alright, hopefully that helps. If you have any other questions on anything like that or any other questions from the ones we did in class, be sure and ask, and I'd be happy to help you out. Alright, see ya.